Class 11th Chemistry. We were discussing Unit 7 Equilibrium, and in this video we will discuss about Ionic Equilibrium in solution and Arrhenius Concept of acids and bases. First come to Ionic Equilibrium in solution. Equilibrium involving ions in aqueous solution is called Ionic Equilibrium. For example, Fe3 plus aqueous plus SCN minus, that is thiocyanate ion aqueous, and it form FeSCN2 plus aqueous. This is one of the example of ionic equilibrium. Michael Faraday classified the substances into two categories based on their ability to conduct electricity, and these are electrolytes and non-electrolytes. Electrolytes are the substances that conduct electricity in their aqueous solutions, while non-electrolytes are the substances that do not conduct electricity in their aqueous solutions. Faraday further classified electrolytes into strong and weak electrolytes. Strong electrolytes on dissolution in water dissociate almost completely into ions, for example sodium chloride, while the weak electrolytes only partially ionize into ions, for example acetic acid. In a weak electrolytes, equilibrium is established between ions and the unionized molecules. For example, if we dissolve acetic acid into water, then this is the equilibrium setup. This is unionized acetic acid and these are its ions, acetate ion and hydrogen ion. Acids, bases and salts come under the category of electrolytes and may act as either strong or weak electrolytes. Now, there are two words. One is a dissociation and another is ionization. Just we will try to understand what is the difference between these two processes. Dissociation refers to the process of separation of ions in water already existing as such in the solid state of the solute. For example, as in sodium chloride. Simply we can say ions are already existing, and when we dissolve these compounds in the water, these ions separate. For this process, we use the word dissociation. On the other hand, ionization corresponds to a process in which a neutral molecule splits into charged ions in the solution. Simply we can say when molecule itself does not contain any ion, but it may be a polar species, and when we dissolve in the water, it will split into charged ions. Then this process is referred as ionization. Here in this book, we shall not distinguish between the two, that is dissociation, ionization, and use the two terms interchangeably. Okay. Now acids, bases and salts. First come to acids. Hydrochloric acid present in the gastric juice is secreted by the lining of our stomach in a significant amount of 1.2 to 1.5 liter per day and is essential for digestive processes. Acetic acid is known to be the main constituent of vinegar. Lemon and orange juices contain citric and ascorbic acids, and tartaric acid is found in tamarind paste. As most of the acids taste sour, the word acid has been derived from a Latin word acidus, meaning sour. Acids are known to turn blue litmus paper into red and liberate dihydrogen, that is hydrogen gas, on reacting with some metals. Bases. Bases are known to turn red litmus paper blue, taste bitter and feel soapy. A common example of a base is washing soda used for washing purposes. Salts. When acids and bases are mixed in the right proportion, they react with each other to give salts. And the reaction between acid and base is also known as a neutralization reaction. Some commonly known examples of salts are sodium chloride, barium sulfate, sodium nitrate. Sodium chloride, also known as common salt, formula is NaCl, is an important component of our diet and is formed by reaction between hydrochloric acid and sodium hydroxide. Dissolution of sodium chloride in water. NaCl exists in solid state as a cluster of positively charged Na plus and negatively charged Cl minus, that is chloride ions, which are held together due to electrostatic interactions between oppositely charged species. The electrostatic force between two charges are inversely proportional to dielectric constant of the medium. Water, a universal solvent, possesses a very high dielectric constant of 80. Thus, when NaCl is dissolved in water, the electrostatic interactions are reduced by a factor of 80, and this facilitates the ions to move freely in the solution. Also, they are well separated due to hydration with water molecules. Let us try to understand with the help of this diagram. This is a cluster of NaCl. Oppositely charged ions are held together. When we dissolve this into the water, Na plus and Cl minus separates, dissociates. Okay, and this Na plus is hydrated. Hydrated means this is negatively charged, and water is a polar molecule. In this case, oxygen is partially negative charge and hydrogen are partially positive charge. So this partially charged oxygen atom of these water molecules surround this Na plus. In the same way, this Cl minus, which is negatively charged, and it is surrounded by the partially positive charged hydrogen of water. This is called hydration. Okay, in this way sodium chloride is dissolved in the water. Now, Arrhenius concept of acids and bases. According to Arrhenius theory, acids are substances that dissociate in water to give hydrogen ions, that is H plus, and bases are substances that produce hydroxyl ions, that is OH minus in water. We can represent this reaction. This is HX. This is one acid. When we dissolve in the water, it forms H plus and X minus. Okay, and actually this H plus, what is this H plus? Actually this H plus is a bare proton. Okay, H plus is formed from the hydrogen atom. In hydrogen, in the nucleus there is one proton and there is one electron around the nucleus. And when this electron is removed, we will get the hydrogen ion. So we can say this hydrogen ion is only the proton. Is very reactive and cannot exist freely in aqueous solutions. Thus, it bonds to the oxygen atoms of a solvent water molecule to give trigonal pyramidal hydronium ion, that is H3O plus. You can also write this. Clear? So, this reaction can also be represented like this: HX plus H2O. Then this will give H3O plus, that is hydronium ion, and this is X minus. In the same way, this is base MOH. When dissolved in the water, it will give M plus ion and OH minus ion. The hydroxyl ion also exists in the hydrated form in aqueous solution like this, H3O2 minus. Simply we can say when this OH minus is react with the H2O, we will get this species. Okay, there is one limit, some limitations of this concept. it is applicable only to aqueous solutions. Okay, and it does not account for the basicity of substances like ammonia, which do not possess a hydroxyl group. Ammonia is basic in nature. Okay, but on this concept we can't explain its basic nature because it does not contain OH minus ion. Okay, thank you. Subscribe my channel to get the new videos of this chapter.